Hello everyone. Hello everyone. I am Pavni. Today I am going to explain my internship project, which is washing machine simulation using Pixim Lab. Uh, Chip at Information Technology Power Limited. During this internship, I have learned language, embedded C language, microcontrollers like PIC 16F877A. I also learned its peripherals like LED, digital keypad, CLCD, timers, buzzers, and fan. And also I learned what is an embedded system and types of embedded systems. What is an embedded system? An embedded system is a microcontroller or a microprocessor based system designed to perform a specific task or a function within a large system. It performs only one specific task repeatedly. It also uh, responds to the inputs instantly or within a strict limit time. Combination of it is a combination of software and hardware. It is also small. It is also a small in size and optimized for limited hardware resources. Types of embedded systems. There are two types of embedded systems. One is based on performance and functional requirements, and the other one is based on performance microcontroller. Based on performance and functional requirements, there are four types. And real-time embedded systems. These are uh, these are these systems give outputs within a strict limit time, like airbag system in a car. Network embedded system. These systems are connected to a network and communicate with other systems like smart home devices, smart lights, ATM machines. Mobile embedded systems. These are compact and portable embedded devices with limited resources. Example smartphones, digital watches, GPS navigation devices. Standalone embedded systems. These systems work independently without needing a host system. Example washing machine, digital camera. Coming to the based on performance microcontroller, there are three types. Small scale embedded system. This is using 8-bit or 16-bit microcontrollers, low memory and processing power. Example TV remote control and electronic toys. Medium scale embedded systems. These use 32-bit microcontrollers or DSPs. These are more complex than small scale systems. Example automated vending machines, biometric systems. Large scale embedded systems. These are very complex systems. These use 32-bit or a 14-bit process, real-time OS, and powerful interface. Example aircraft, autopilot systems, medical imaging systems. Coming to the components of embedded systems, there is one central block which is called a processor. It executes the program instructions stored in a memory. It also handles and controls the uh, data processing. Flash memory. It is used to store program code, contains remain even after a power is turned off. It is a non-volatile memory. RAM memory. It is a volatile memory used for temporary data storage and driving program execution. Timers and counters. These are used for time delays, event counting, pulse width measurement, etc. Interrupt controller. It monitors and prioritizes interrupt signal. It also helps the processor to respond quickly. Serial communication interface. For serial communication interface with other devices uses using protocol like UART, SPI, ITC. It also sends and receives data of 1 bit at a time. Parallel interface. It allows the data transfer 8 bit or at a time, 8 bit or more at a time. It is used to connect to devices and displays, prints, etc. Application devices, RTC, ADC, etc. These are external modules connected to the microcontrollers. Interfacing driver circuits. It acts as a bridge between microcontrollers and real world devices like motors, LEDs, sensors. ensures proper voltage control current levels. Output devices like LEDs, buzzers, displays, etc. connected to show or microcontroller. Power blocks, which are VSS and VDD, supplies power to the microcontroller and its components. VCC means voltage and VSS means ground. Overflow of this is power is applied to VCC and VSS. Processor executes instructions from ROM. RAM stores temporary data. Interfaces handle communication like serial and parallel. Timers and interrupts manage events. Output is shown via connected devices. Application specific components like ADC and RTC are accessed as. Now coming to the project. The main to design this project, we used PIC16F877A microcontroller. Why only PIC16F877A? Because with MPLAB timers and interrupts suitable for real-time control. These are built-in ADC, sufficient input IO pins for controlling multiple devices. Features of PIC16F877A: 8-bit architecture. It has a address bus of 13-bit, data bus of 8-bit. It has a data memory 368 bytes. It has a program memory of 14 KB. It has a clock speed of 20 megahertz. It also supports the serial communication like SPI, UART. It has 40 pins, means 5 ports in total. Port A contains 6 pins, port C contains 8 pins, port D also contains 8 bits, and port E contains 3 pins. The main objective of this project is to design and simulate a washing machine using PIC16F877A microcontroller and, programmed in MPLAB XIDE and simulated in PixieLab, integrating components such as fan, buzzer, timer, CLCD, digital keypad, and LEDs to provide a fully functional automated cloth washing process. The system aims to ensure accurate timing, eco-friendly, user-friendly operation, and safe execution of washing and to remove the clothes. This is pin diagram of PIC16F877A. It contains the 40 pins, which are in total 5 ports. So to design this project and to design and simulate this project, we used softwares like SimLab, MPLab XIDE, XC9 compiler. In PiximLab, pick Genius PIC16F8 MC board we selected. Requirements of this project is in PiximLab it's LCD. It should display power on screen. As soon as board is reset, should display like press key 5 to power on washing machine on the CLCD. If you press switch 5, then it should show that powering on the washing machine. Requirement number 2: washing program screen. In the washing program screen, it mainly contain following washing options like daily, heavy, delicate, whites, stain wash, eco, cottons, woolens, bed sheets, rinse dry, dry only, wash only, and aqua store. Using this keypad switch 4, we can scroll between the options available. A long press of switch 4 will select the option of highlighted with a star. Now requirement number 3 is water level skin will get by long pressing the switch 4 um, for and it also shows the options like auto, low, medium, high. That's it. And Requirement number 4 is start screen. Once the washing program and water level is selected, provide user option to start the screen. If we press switch 5, start the mission and display the function selected and time taken, then switch to function screen. Requirement number 5 is function screen. Once a mission is started, displays the function ongoing. It can be wash or rinse or spin. Along with the display, the time is left on the CLCD display. Completion status screen. Description. Once all programs are completed, display notification programs completed to remove the clothes on CLCD and the buzzer will on for certain time. Now, from this project, the conclusion is the washing machine simulation using PiximLab serves an effective tool for living and applying concepts in embedded systems. It offers experience that complemented theoretical knowledge and provided a foundation for further exploration in the field of automation and control systems. I would like finally I would like to thank Emertxe Information Technology Powered Limited for giving me this internship opportunity. Thank you. Now I would like to show my project demonstration. So this is my Pixim Lab PIC 16FA77A board C board. Now so to this my washing machine file. This is so in this MC board, this is a fan and this is a buzzer, and these are LEDs, digital keypad, and reset button. When I loaded this my washing machine program file, it is asking me to press switch 5 to power on the washing machine. So now I am pressing switch 5 to power on the washing machine. When I press switch 5, it is displaying that powering on washing machine. Now it is showing me washing programs like heavy, daily, delicate, stain wash, woolens, bed sheets, whites, eco cottons, like that. If I do long press or switch 4, it shows water level. Let's see. So it is showing like auto, low, medium, max, high, like that. If I do long press, then it asks me it asks me to press switch 5 to start and switch 6 to stop. So here it is asking me to press switch 5 to start the system, to start the mission, switch 6 to stop the mission. Now I want to start the system, so I am pressing switch 5. So here the countdown, the program is selected for stain wash. The time was started countdown. Now if I want to pause this system, I will press switch 5. Again, if I want to resume, I will press switch 5. When I press switch 5, the fan starts rotating, and once the program is completed, time completes, the buzzer will ring, and it it displays on the screen that please remove the clothes. Let's see whether it shows or not. Now if I in this during this time, if I press RB not button, it it makes the buzzer sound, and it tells us to close the door, and door is open. So door is so here it is displaying the door is open. Please close the door. So here the time was completed. It is program is completed. It is asking to remove the clothes. So this is my uh, Pixim Lab demonstration. Thank you.